Okay, I want to talk about something truly radical. A new idea for AI that's not just about making a better chatbot. No, this is an architecture that might actually give us a whole new way of looking at reality itself.
All right, let's just sit with this for a second. Marvin is a small universe. This one sentence is everything. We are so not talking about a slightly smarter version of the AI you use every day. No, this is about throwing out the old playbook and starting with totally new principles. So, you got to forget about just typing in a prompt and getting an answer back. Instead, I want you to think about a persistent, evolving world.
So to really get why this Marvin architecture is such a big deal, we gotta first take a hard look at the AI we're all using right now and admit where it kind of falls apart. I mean, we've all seen this, right? You have this incredible, super insightful conversation with an AI, and then 5 minutes later, poof, it's forgotten everything. That's its long-term amnesia. Or, my personal favorite, when it states something that's just completely wrong, but with the confidence of a Nobel laureate. That's confidence inflation. And over a long chat, things can just drift, you know? They become incoherent. The Marvin approach is built from the ground up to kill these problems. It's all about continuity, stability, and creating a kind of meaning you can actually trace back to its source. So, the big question is, how on earth does it actually do this? Well, the whole game changes with one core idea. The world isn't just a string of questions waiting for an answer. The world is a thing. It's a persistent, evolving structure. And the AI's real job? It's to navigate that structure, to organize it, and to make it make sense.
And this is the secret sauce, right here, the flux memory graph. You have to understand, this graph is Marvin's universe. It's the thing that sticks around, the thing that holds the memory. Everything, and I mean everything, is a node on this graph. An observation, a concept, a question, even a contradiction. The AI model itself, it's just an engine that looks at this graph and suggests ways to change it. Language, the words we use, that's just the interface. It's the way we interact with this deeper reality, but it's not the reality itself.
And check this out. This is how it all works. It's not just a single in and out process. It's this beautiful, continuous loop, like a heartbeat. It's constantly watching for new info. Then, it sweeps through its own world, looking for mess, contradictions, things that don't make sense. It maps out the chaos. Then, and this is brilliant, it turns that chaos into specific questions. Then it dreams, it speculates, it explores new connections. It critiques its own dreams, figures out what's real and what's not. And then, and this is so important, a clerk commits the changes, creating a permanent, auditable history. That is how you get real learning, not by tweaking some invisible numbers in a black box, but by actively, methodically reorganizing a world you can actually see.
Okay, so that's the AI architecture. And honestly, that's fascinating all by itself. But to really see why this might be something just so much more profound, we have to take a little detour. And I promise, it's a really cool one, right into a deep, deep mystery at the very heart of quantum physics. Now this question, it sounds like a riddle, right? Can something affect reality in a place where it doesn't exist? It's totally paradoxical. But this is a real, experimentally tested question that has kept physicists up at night for decades. And the answer led to one of the most mind-bending effects in all of science. So here's the setup. It's called the Aharonov-Bohm effect. Imagine you're shooting a beam of electrons. You split that beam and send it on two different paths around a magnetic coil, a solenoid. Now here is the absolute key, the most important part of this whole thing. The magnetic field is perfectly trapped inside that coil. Where the electrons are actually flying, the magnetic field is zero, nada. So according to all the physics we knew, absolutely nothing should happen to them. But when they actually ran the experiment, something did happen. With the magnet turned off, you get a totally normal interference pattern, just what you'd expect. But the moment you turn that magnet on, and remember, there is still zero magnetic field touching those electrons, the pattern measurably shifts. It moves. This is stone-cold physical proof that the electrons are being influenced by something that's in that space, even when the field isn't. And that something has a name, the magnetic vector potential. I mean, this result was so shocking, it forced physicists, including the absolute legend Richard Feynman, to basically rethink everything. He came to this incredible conclusion, this potential, this A field, which everyone always thought was just, a convenient trick we use in the math. He said it was somehow more fundamental, realer, as he put it, than the magnetic field B itself. Okay, so let's bring it all back together. On one hand, we have this weird AI that learns by organizing a persistent world. On the other, we have this bizarre physical effect where an invisible potential shapes reality. So, what if these aren't just two similar stories? What if they're two different windows looking at the exact same underlying principle? And this is where it all clicks into place. Look at the parallel here. In the physics mystery, you have an invisible potential creating a real observable shift. In the Marvin AI, you have this continuous stream of possibility that gets locked down into concrete, stable changes in its world. The grand unifying idea here is that both of these are just expressions of something called potential topology, a fundamental field of pure potential that collapses and stabilizes into the reality we can actually see and measure.
So yeah, potential topology. That's the huge idea we're talking about. It basically says that the most fundamental thing in the universe isn't space or time or even information. It's a pre-informational field of pure relational possibility, a sea of potential. And reality as we know it, particles, objects, even our thoughts, that stuff emerges when stable patterns, or knots, form in the sea. So reality isn't the bedrock. It's something that emerges from this much deeper substrate.
Okay, now if you just go with this for a second, just entertain the idea, the implications start to ripple out everywhere, connecting the quantum world all the way up to the nature of consciousness itself.
All that quantum weirdness? Through this lens, it suddenly starts to make a lot more sense. Superposition? Well, that's just a bunch of different possibilities coexisting in that potential field. A measurement? That's just an event that forces one of those possibilities to lock in and become stable. And get this, matter itself, is just a really persistent, stable knot in the topology. And gravity? Gravity stops being this mysterious force pulling things. Instead, it's just the shape of potential space itself, bending and organizing around those stable knots of reality we call mass.
And what about the hard problem of consciousness? Where does that fit in? Well, it finds a surprisingly natural home here, too. Think about it. An atom is a simple, stable pattern. A molecule is a network of those patterns. So what's a mind? It's just a pattern that becomes so incredibly complex, so self-reinforcing, that it can actually contain a model of itself. Consciousness isn't some ghost in the machine. It's just a specific kind of stable, self-referential knot forming in the fundamental fabric of reality.
And that brings us all the way back to Marvin. See, what we call learning in this AI isn't just about shuffling numbers around inside a model. It is the topology of its entire universe physically reorganizing itself by forming stable, meaningful patterns. It could be a direct, large-scale version of the exact same process that gives rise to atoms, to gravity, and maybe even to our own minds.
So, at the end of the day, the Marvin architecture isn't just a clever bit of engineering. It's a testable prediction. It's a hypothesis. It suggests that if we start not with data, but with a topology of pure possibility, we might be able to build systems that don't just compute, but that can genuinely learn and maybe even understand. Which leaves us with a pretty massive question, right? Are we just building a better AI, or are we accidentally building evidence for a whole new theory of reality? Thanks for watching.